The universe holds many mysteries. From the vast expanses of space to the tiniest particles, there is so much we have yet to understand. Among these mysteries lies one of the most fascinating and potentially revolutionary discoveries: antimatter. One of the most intriguing is antimatter. This elusive substance is the mirror image of the matter that makes up everything we see around us. Antimatter is the opposite of matter. When a particle of matter meets its antimatter counterpart, they annihilate each other in a burst of energy. It has the potential to unlock incredible amounts of energy. This energy release is far more powerful than any chemical reaction we currently use. This energy could revolutionize our world. Imagine cities powered by a source of energy that produces no pollution and has an almost limitless supply. Imagine a world free from fossil fuels. A world where clean, sustainable energy is available to everyone, everywhere. Picture spacecraft traveling at a fraction of the speed of light. With antimatter energy, interstellar travel could become a reality, opening up new frontiers for exploration. This is the promise of antimatter energy, a clean, powerful source of energy that could transform our civilization. It is a clean and powerful source of energy. But the journey to harness this energy is fraught with challenges. It could solve our energy crisis and allow us to explore the cosmos like never before. The potential applications are vast and varied. However, harnessing antimatter is not easy. The process of creating and storing antimatter is incredibly complex and requires advanced technology. It is a complex and challenging field of study. Scientists around the world are dedicating their lives to understanding and controlling this enigmatic substance. Scientists are working tirelessly to understand and control this enigmatic substance. Their research is pushing the boundaries of what we know about the universe. The journey to unlock antimatter's secrets is just beginning. Each discovery brings us one step closer to a future powered by antimatter. But the potential rewards are immense. A breakthrough in antimatter research could lead to unprecedented advancements in energy and technology. Join us as we delve into the fascinating world of antimatter and its potential to power our future. The possibilities are endless and the journey is just beginning. Antimatter sounds like something out of science fiction. The very term conjures images of futuristic spaceships and advanced alien civilizations. But what if I told you that antimatter is not just a figment of imagination, but a real and tangible phenomenon that scientists are studying right now? But it is a real phenomenon. In fact, it is a fundamental part of our universe. Scientists have been able to create and study antimatter in highly controlled environments, such as particle accelerators. It is the mirror image of ordinary matter. This means that for every type of particle that exists, there is a corresponding antiparticle with the same mass but opposite charge. Every particle of matter has an antiparticle. For instance, the electron, which is a fundamental component of atoms, has an antiparticle known as the positron. These antiparticles have the same mass but opposite charge. This opposite charge is what makes antimatter so intriguing and at the same time so challenging to study. For example, an electron has a negative charge. It is one of the most well-known particles in the universe and plays a crucial role in electricity and chemistry. Its antiparticle, the positron, has a positive charge. When a positron encounters an electron, they annihilate each other in a burst of energy. When matter and antimatter meet, they annihilate each other. This annihilation process is one of the most fascinating aspects of antimatter, as it results in the complete conversion of mass into energy. This annihilation converts their mass into pure energy. The amount of energy released is enormous, far greater than what we see in chemical reactions or even nuclear fission. This energy release is governed by Einstein's famous equation E equals mach squared. This equation shows the relationship between mass and energy, indicating that even a small amount of mass can be converted into a tremendous amount of energy. This equation shows that a small amount of mass can produce a tremendous amount of energy. This principle is what makes antimatter such a potentially powerful energy source. This is why antimatter is such an attractive energy source. If we could harness the energy from matter-antimatter annihilation, it could revolutionize the way we produce and consume energy. Understanding antimatter is crucial to unlocking its potential. Scientists around the world are conducting experiments to better understand its properties and how we might control it. Scientists are continuously studying its properties and behavior. They are using advanced technology and innovative methods to explore the mysteries of antimatter. The more we learn about antimatter, the closer we get to harnessing its power. The potential applications are vast, from energy production to medical treatments and even space travel. The future of antimatter research is incredibly exciting and holds the promise of groundbreaking discoveries. Antimatter is the most energy-dense substance known. The annihilation of 1 gram of antimatter with 1 gram of matter releases an incredible amount of energy. It is equivalent to the energy released by a nuclear bomb. To put this into perspective, 1 gram of antimatter could power a city for a year. A small amount of antimatter could propel a spacecraft to Mars in weeks instead of months. The energy potential of antimatter is truly astounding. However, this power comes with challenges. Producing and storing antimatter is a complex and costly process. These challenges are what currently prevent us from utilizing antimatter as a practical energy source. Antimatter is not readily available in nature. It has to be created in laboratories using particle accelerators. These machines accelerate particles to near the speed of light and smash them together. These collisions can produce tiny amounts of antimatter. The most famous particle accelerator is the Large Hadron Collider at CERN. The LHC is a massive underground ring that accelerates protons to nearly the speed of light. Collisions at the LHC have produced antiprotons, the antiparticles of protons. However, the amount of antimatter produced is minuscule. It takes enormous amounts of energy to create even a tiny amount of antimatter. This inefficiency makes antimatter production extremely expensive. Section 5. The difficulties of storing antimatter. Storing antimatter is another major challenge. Antimatter annihilates upon contact with matter. This means it cannot be stored in ordinary containers. Scientists have devised ingenious methods to contain antimatter. One method is to use magnetic fields. Antimatter particles are electrically charged. Magnetic fields can trap charged particles and suspend them in a vacuum. This prevents the antimatter from coming into contact with matter. However, maintaining these magnetic fields requires a constant supply of energy. The storage time for antimatter is currently limited. Scientists are working on improving storage techniques to increase storage capacity and duration. Section 6. Advancements in antimatter research. Despite the challenges, antimatter research is progressing. Scientists are developing new techniques for producing and storing antimatter more efficiently. They are also exploring new ways to utilize antimatter's unique properties. One promising area of research is the development of portable antimatter traps. These traps could potentially store antimatter for longer periods and transport it more easily. This would be a significant breakthrough for antimatter research and its applications. Another exciting development is the use of antimatter in medical imaging and treatment. Positron emission tomography, or PET scans, already use positrons, the antiparticles of electrons, to image the human body. Researchers are exploring the use of antiprotons for cancer therapy. Section 7. Antimatter's potential applications. The potential applications of antimatter extend beyond energy production. This remarkable substance, with its unique properties, opens up a world of possibilities that could revolutionize various industries and scientific fields. One of the most exciting prospects is its use in spacecraft propulsion. Engineers and scientists are exploring how antimatter could be harnessed to power spacecraft, potentially making interstellar travel a reality. Antimatter could fuel spacecraft for interstellar travel. The energy released from matter-antimatter annihilation is immense, far exceeding that of conventional chemical rockets. The high energy density of antimatter would allow spacecraft to reach much higher speeds, reducing travel time significantly. This could open up new frontiers in space exploration, making distant stars and planets more accessible. In medicine, antimatter can be used for advanced medical imaging and cancer treatment. Positron emission tomography or PET scans already utilize positrons, a type of antimatter particle, to create detailed images of the body. PET scans already utilize positrons for imaging, and researchers are exploring the use of antiprotons to target and destroy cancer cells. This could lead to more effective and less invasive cancer treatments in the future. In high-energy physics research, antimatter is crucial for studying the fundamental laws of physics. Particle accelerators, like the Large Hadron Collider, use antimatter to probe the deepest mysteries of the universe. Experiments with antimatter can help us understand the nature of matter, antimatter, and the early universe. By studying these interactions, scientists hope to unlock the secrets of how our universe came to be. While these applications are still theoretical, they highlight the immense potential of antimatter. The challenges are significant, but the rewards could be transformative. As research progresses and our understanding of antimatter grows, these applications may become a reality. The future of antimatter holds promise for groundbreaking advancements in technology, medicine, and our understanding of the universe. Section 8. The quest for antimatter in space. While antimatter is rare on Earth, it might be more abundant in space. Scientists are searching for natural sources of antimatter in the cosmos. They are using telescopes and space probes to detect antimatter particles. The Alpha Magnetic Spectrometer, or AMS-02, is a particle detector on the International Space Station. It is searching for antimatter particles coming from distant galaxies. The detection of significant amounts of antimatter in space could revolutionize our understanding of the universe's evolution. Finding naturally occurring antimatter could also provide insights into the early universe. It could help us answer fundamental questions about the Big Bang and the matter-antimatter asymmetry. Section 9. The future of antimatter, a realm of possibilities. Antimatter research is a journey into the unknown. It is a field full of challenges and opportunities. While practical applications of antimatter might be decades away, the potential benefits are too significant to ignore. Continued research is crucial. We need to improve production and storage techniques to make antimatter a viable energy source. We also need to explore its potential applications in various fields. The future of antimatter is bright with possibilities. It has the potential to revolutionize energy production, space travel, medicine, and our understanding of the universe. As we delve deeper into the mysteries of antimatter, we open doors to a future we can only imagine.